Hello everyone, this video is about transforming exponential and logarithmic equations to linear form. To verify experimental relationships, line of best fit must be analyzed. Therefore, data must be processed to a linear form. Manipulate equations into y equals mx plus c. From here we can estimate the m and c from the graph, and then we calculate the variable of interest. So for example, here we have this question. The variables x and y satisfy the equation y equals, so the equation is y equals capital K x to the power of K and m constants. The graph of L and y against L and x is a straight line passing to the points. Find the values of K and m. Okay, so as you can see, we gotta make this Ln something. So let's just Ln both sides. So Ln y, we have Ln y equals Ln kx to the power of m. On the right, we can split this into ln k plus ln x to the power of m, and we can use the power rule and bring this m out of the log, so we have m times ln x. So I'm just rewriting it here. So this means we have ln y equals m times ln x plus ln k, which is just like y equals mx plus c. So usually when we have the y-axis and the x-axis, we have this straight line, but this time the y-axis is the ln y-axis and the x-axis is the ln x-axis. So it's the same thing, it's also linear. How do we find the value of k and m? Well, we can find the gradient from this data here. The gradient would be, if you just draw like a triangle, the height of the triangle is 0.2 minus 2.0, so it's 8.2, and that's the rise. The run is 6 minus 0, so it's 6, which means the gradient is 8.2 divided by 6. So we can find the m right away, and to find the ln k, the ln k is actually the y-intercept, and the y-intercept here is simply 2.0, or just say 2. So since the m, which the gradient is 8.2 over 6, we have the value right away. You can simplify. Now the y-intercept, the ln k, is 2.0, or just say 2. So the k is e to the power of 2, e squared. The variables x and y satisfy the equation. By taking natural logarithms, show that the graph of y against x is a straight line. Find the exact value of the gradient of this line. So y against x is a straight line by taking natural logarithm. So let's just ln both sides. Ln 5 to the power of y equals ln 3 to the power of 2x minus 4. So we have the power rule, we can bring it out of the logarithm. So we have y times ln 5 equals 2x minus 4 times ln 3. So this is just like y equals 2x minus 4. Okay, let's just use 2x minus 4 times ln 3 divided by ln 5, which is actually log 3 base 5, and that is equal to we do this 2x times, so it's just like 2 times ln 3 over ln 5 times x minus 4 times ln 3 over ln 5. So the gradient is of course this part here. This is the gradient. So to answer part A, we can say that the gradient, usually we use m for gradient, is 2 times ln 3 over ln 5. Yeah, that's not how we write the 3. Well, it's actually also equal to ln 2 times log 3 base 5, or we can also say it's log 3 squared, which is 9 base 5. So all possible for part A. Part B, the line intersects the x-axis at P and the y-axis at Q. Find the exact coordinates of the midpoint of PQ. So for B, well, to find the Q, that's pretty simple. The Q is the y-intercept. The y-intercept is this guy here. So the Q is when the x equals 0, the y equals a negative. So using the same kind of rule here, we have 3 to the power 4. So it's actually log 3 to the power 4 is not 81 base 5. And for the Q, wait, that's the Q. The P is when the y equals 0. So when the y equals 0, of course the x is exactly 2. So if you replace this y with 0, the x must be 2, of course. So yeah, if you think about it, so the P is 2, 0. Question is the exact coordinates of the midpoint. So the midpoint, let's say midpoint, that is exactly in the middle between 0 and 2, so it's 1, and exactly in the middle between 0 and minus this, so it's just minus 1/2 log 81 base 5. And well, that's also equal to 81 to the power of minus 1/2 is 1 over 9, so we can say log 1 over 9 base 5, also possible. Or you can also say log 9 base 1 over 5, also possible. So I'm just going to use minus log 9 base 5. Alright, that's it. I'll see you again next time.